Almost every AI tool you use at work has one thing in common. Your request leaves your computer, your document travels through the internet, a cloud model does the thinking, and the answer comes back. But the default may be starting to change, and the consequences is much bigger than where ChatGPT lives. On August 10th, Meta released Muse Glimmer, an open-weight 30 billion parameter model built for always-on local agent workflows. Meta says it can run on a Mac or a PC with a single consumer GPU. That's not a vague research promise. The weights are available now. Now one GPU does not mean every old laptop. Meta compressed the model's weight to under 20 gigs and describes a 24 to 32 gigabyte memory envelope. Think newer, higher-end hardware, not the bargain laptop in the kitchen. Still, a capable agent moving from data center to one personal machine is the shift to watch. But Muse Glimmer is not really the story. A benchmark review would be stale in a week. The story is what this represents. AI work beginning to move from somebody else's cloud into your own machine. So let's ignore the model leaderboard and ask the useful question, what changes for normal professionals? First, your files may not have to leave your computer. Today, a typical AI workflow sends a document across the internet to a provider, waits for processing, and returns a result. That can be perfectly appropriate, but it also creates another copy, another route, another policy decision, and another system your organization has to evaluate. A local workflow can be much shorter. Document, local model, result. The file can stay on the machine while the model summarizes it, classifies it, compares it, or drafts from it. For confidential project notes, internal procedures, contracts, and customer materials, reducing unnecessary movement can be valuable all by itself. Important distinction, local does not automatically mean secure. The model, the app around it, its internet access, permissions, logs, plugins, and the health of the computer still matters. Local can reduce one class of exposure, the file leaving the device, but it doesn't erase security work. It changes the threat model. Second, AI could become more like equipment and less like a meter. Cloud AI usually combines subscriptions, usage credits, API calls, token charges, or some mixture of them. Microsoft Copilot, coworker, for example, calculates task cost from model use, context retrieval, tool calls, and runtime. More work consumes more compute, and the meter keeps moving. The usage model makes sense because somebody else owns the data center, but it also makes long-running agents harder to budget. Ask the system to review more files, call more tools, reason longer, and run overnight. The value may rise, but so can the bill. For a team, success can become unpredictable spend. Local AI shifts more of that cost up front. You buy capable hardware, supply the electricity, maintain the software, and then each additional run may feel close to free. Not actually free. Hardware ages, power costs money, and people support the system. For repetitive internal workloads, a fixed capacity model can be a powerful business story. Third, your AI could keep working with no internet connection. That sounds minor until you picture the moment when the cloud is exactly what you cannot rely on. A plane, weak hotel Wi-Fi, a secure facility, a remote work site, or a network outage 5 minutes before a deadline. Imagine loading 17 status reports before a flight. In the air, the local agent finds the recurring blockers, identifies overdue decisions, builds the steering committee summary, and creates a draft action log. Nothing needs to upload at cruising altitude when you land. You review the work and decide if anything should connect to the outside world. Fourth, and this is the biggest workplace consequence, companies could build private internal AI workers around their own knowledge. The worker could read policies, procedures, templates, project documents, and internal reference materials while keeping the default work inside a company-controlled environment. This is a very different adoption conversation from send everything to a public chatbot. For a project manager, the request might be review these 17 status reports, find schedule risk, unresolved decisions, cross-team dependencies, and changes since last week. Then create a one-page steering committee summary using our template. This is narrow, repetitive, document-heavy work, and the output still goes to a human before anybody acts on it. HR could compare job descriptions with the company template. Finance could categorize internal reports and flag unusual changes. Operations could find contradictions across standard procedures. Legal could prepare a first-pass clause comparison. The point is not that one local model replaces these professionals. It gives each of them a private first-pass worker for bounded tasks. And a local worker still needs boundaries. Reading files is different from editing them. Drafting a message is different from sending it. Recommending a change is different from improving it. The strongest design is not give the AI everything. It is minimum access, visible logs, narrow tools, and human approval where the consequence is hard to reverse. Now for the credibility check. Cloud AI is not disappearing. Local models have limits. Your machine has finite memory, finite speed, and finite battery. Setup can be technical. Updating models and tools becomes your responsibility. And the most capable frontier system may still require far more compute than one device can provide. The cloud remains excellent when you need maximum capability, huge context, many connected services, fast upgrades, easy setup, or a task that should keep running after your laptop is closed. OpenAI's own work guidance makes this split explicit. Local work can use files and apps on your computer. Cloud work can keep running after the device turns off. Local wins when privacy, offline access, customization, predictable capacity, and proximity to your own files matters more than frontier scale intelligence. It may also be the better choice for a small, repeatable task that doesn't need the world's smartest model, just a competent model that can follow the same process every time. So the future probably is not local versus cloud. It's deciding where each part of the work should happen. A local model can inspect sensitive files and remove unnecessary detail. A cloud model can handle the hardest reasoning. Then a local system can format the result and wait for approval. The workflow routes the work deliberately. You don't need to download Muse Glimmer tomorrow to benefit from this shift. The useful move is learning to separate the tasks from the model. Ask what data does this task touch? How capable does the model need to be? And what actions should remain behind approval? Those questions survive every product launch. If this data is sensitive, the task is bounded, and the required model is modest, local deserves a serious look. If the work needs broad web research, enormous context, premium reasoning, or nonstop execution while your device is off, cloud probably wins. If both are true, design a hybrid workflow instead of forcing one answer. The best first experiment is boring, a repetitive document-heavy workflow with a clear output and no automatic sending. Gather a safe sample, define the template, run it locally if your hardware allows, and compare the result with your current cloud tool. Measure quality, speed, cost, privacy, and how much supervision is really needed. Meta's announcement matters because it makes the direction visible. Your next AI coworker may not live in somebody else's cloud. It may live on the machine already holding your work. The winning question will not be which model is best. It will be where should this work happen? Subscribe to the Promptwise and tell me which workflow you would move local first.